Hello everybody, today we're taking a look at Unit 8, Big Idea 1, using the multiplication rule. The I can statements that go along here are: I can use an area model to determine probability of two independent events. I can compute conditional probability using a table. And I can determine independence among events and apply multiplication rules when events are independent or dependent. Now for this video, we are going to focus primarily on this first I can statement here. Figuring out how to use an area model to determine probability of two independent events. And so for our problem today, we are going to use shooting free throws as kind of our example of how we're going to use an area model. So say LeBron James, he makes 75% of his free throws. And suppose he gets fouled in the last seconds of a basketball game and his team is trailing by 1 point. He has two free throws to take to either win, tie, or lose the game for his team. Use an area model to find the probabilities of these three events. So our three events are: he either scores 2 points, and that will win the game for his team. He could make one of the shots and miss the other, so they'd only get 1 point there. In that case, they would tie the game. And then he could miss both shots and make 0 points. In that case, they would lose the game. All right. So we need to find the probabilities of these three outcomes. And we're going to use this area model to show how that works. Okay. So when we do an area model, we use two of the edges to represent the two events. And the two events in this case are the two free throw shots that he's going to take. So on one axis, I'm going to have shot number 1. And on the other axis, I'm going to have shot number 2. Now, when I come down this edge right here, I have two options when he takes the shot. He's either going to make the shot or he's going to miss the shot. Now, this tells us here that 75% of the time, he's going to make his free throw shot. So along this axis, I want to break this up in a way that shows that he makes 75% of the time and he misses 25% of the time. All right, so I don't want to divide this equally like this. I want to break this down something more like this here, where this section up here represents he's going to make the shot, and I'll call this 75% or 0.75. And down here, he's going to miss the shot, and that's going to be a 0.25 or 25%. So as you can see, the area is broken up into kind of to show that he's either going to make the shot more than he misses it, and it's proportionate. So visually, you can see that he's making 75% of the time, missing 25% of the time. Now shot 2, the same thing applies there. He's going to make 75%. So he's going to make 0.75. And I can break this area up like this. And he's going to miss 0.25. All right. So now we have this area is now all broken up into the possible outcomes of his two shots. So kind of like a Punnett square, you take the combination of both sides and you bring them together to find that combination. So right here, he's going to make and make. So this area right here represents the times that he's going to make both shots. This area over here represents shot 1, he makes it. But shot 2, he misses it. Okay. This area right here, he misses shot 1. Shot 2, he makes it though. In this little square here, he's going to miss shot 1 and he's going to miss shot 2. All right. So this is kind of our outcome space, and it shows how making both shots looks like it's the most probable outcome in this case. So now what we're going to do is actually determine the probabilities of these outcomes. And what you do is you use multiplication. So what you do is you take the 0.75 here and multiply it by the 0.75 here. So 0.75 times 0.75. And we'll get our calculator out for that. 0.75 times 0.75 for 0.5625. So 0.5625. So that is our probability that he makes both shots. Then I'm going to come over here. This box right here is make the first one and miss the second one. So this is a 0.75 times your 0.25 on here. Calculator for that. 0.75 times 0.25, 0.1875. So 0.1875. This box right here is a 0.25 times a 0.75, right? This combination right here. And it should be the same as this one here, you know, just the order's reversed. So this is a 0.1875 as well. And then the last combination is he misses both. So miss, that would be your 0.25 times your 0.25. And I ran out of room, but that's okay. 0.25 times 0.25 is 0.0625. 0.0625. So back to our original question. The probability that they win the game. He gets 2 points. That represents, what I'm going to do is color code this. So winning the game. That is represented by this area right here, right? He makes both shots. You can see that there. Okay, so there's a very good chance, 0.5625, little bit better than 50% chance that he wins the game for his team. So that's a 56.25% chance that that happens. Next, I'm actually going to go down to this section right here, the 0 points. This is the miss situation. I'm going to do that one in, looks like a purple here. So that is this little area right here. And you can see that's a very small area compared to the whole section here. That area, 0.0625 or 6.25%. And then these last two sections, he makes one and he misses one, or he misses and he makes. So in those two cases, he's actually only going to score 1 point. So these two rectangles here, I'm actually going to do in the same color. I'm going to do it there. This is blue. So what I can do is I can add those probabilities up. The 0.1875 times 0.1875. Oh, that's times. I messed that up. I'm supposed to add them. 0.375. So the probability that he only gets 1 point is adding these two probabilities up. So that's 0.375 or 37.5% of the time. So it looks like he's actually better than 50-50 shot he's going to win the game for the team. Okay. So now suppose a 55% free throw shooter was in the same situation. Show the difference in probabilities of the outcomes. So same outcomes, 2 points they win, 1 point they tie, and 0 points they lose. But let's say it's a worse free throw shooter in this point. So same situation, different shooter. We have shot number 1 and shot number 2 here. But instead of 75%, it's only 55%. So if this is halfway right here, 55% is only about right here. So I'm going to break this big square into the make section is a 0.55. Your miss section is a 0.45, right? Same thing on shot 2. The shots don't really affect each other. He still has 55% chance of making it, even if he misses shot 1. Make is a 0.55, and miss is a 0.45. All right. As you can see, his combination of make is much smaller than LeBron James over here. So 0.55 times 0.55 is 0.3025. And that we're going to make in yellow. And that was the yellow. So this is a 0.3025, or we could also say 30.25% chance he's going to win the game for the team there. So this box right here is where he makes the first shot. That's a make, and then he misses. This would be your 0.55 times 0.45. That's going to equal, I'm going to bring this back up, 0.55 times 0.45, 0.2475. So 0.2475. I'm going to circle that just so I remember that's it. That one's there. Similar case here, except in this time he misses, and then he makes 0.45 times 0.55. Just the multiplication's just reversed from this one, so I don't need to check that. That's 0.2475. And the final box is the combination that he misses, and he misses, which is going to be your 0.45 times your 0.45, which is going to equal your 0.2025. 0.2025. All right. So let's look at this one right here. The probability gets no points. That's going to be your miss. And I boxed that in a purple before, so I'm going to do a similar kind of box here. That is a, forgot to circle those, 0.2025, or you could say it's 20.25%. Go a line there. And then again, this is he makes one and he misses one. This is miss one and he makes one. So both of those cases, he's actually getting 1 point. So the probability of getting 1 point is a combination of this box right here and this box right here. And then I could add these two probabilities up to get your total probability. So 0.2475 plus 0.2475, 0.495. So 0.495, which is equal to 49.5%. All right. So as you can see, using area model, you can determine more visually the probabilities. In this case, more than half of the overall area of this whole section is this make. It shows 56% of it is. So in that case, they win the game 56% of the time. In this case here, 49.5, so basically 50% is made up of these blue sections, which is the case where he makes and he misses, which would be a tie game in that case. So that's about it for showing how an area model works for Unit 8 Big Idea 1. Thank you.